Hi, I'm Seema Mehta at Ampere Computing, bringing to you the memory tagging capability of AmpereOne processors. Multi-tenant containerized environments are the backbone of cloud-native applications, but multi-tenancy can expose the applications to safety vulnerabilities. Memory tagging offers a strong layer of protection, providing robustness and security, so let's explore how it works and why it matters. Memory tagging enables operating systems and application software to allow only validated access to memory using a lock and key approach. The CPU assigns a unique 4-bit tag to every 16 bytes of memory, that is the lock. At runtime, when the software sets a pointer to that memory, the same tag is added to the pointer, and that is the key. Now, with any attempt by any software to access memory, the CPU compares the lock to the key and only allows the access if they match. If there is a mismatch between the pointers and the memory tag, the CPU causes a memory access fault, preventing any further data access. The AmpereOne architecture is built from ground up to avoid exploits like meltdown. And while memory tagging is a system-wide feature, the load store unit of AmpereOne architecture plays a critical part in making sure this is performant. Other architectures do not have built-in support for memory tagging, leaving environments vulnerable to exploits like dangling pointers and buffer overflows, posing significant risks in cloud-native environments where multiple applications coexist without awareness of each other. Some of these applications can be malicious, intended to exploit memory vulnerabilities. AmpereOne's unique implementation of memory tagging allows for a high-performance mode that is precise and efficient. What's unique about Ampere's approach is that it does not use excess bandwidth or memory capacity, so that the feature can be used not only during the software debug, but also during deployment in a production cloud environment. CPU hardware-enforced memory tagging ensures comprehensive protection across the software stack, minimizes performance impact, and reduces the need for extensive code changes or additional dependencies on tools, compilers, or operating systems. The microarchitecture of the AmpereOne CPU is uniquely tuned to minimize impacts on memory capacity or bandwidth, allowing for a high-performance mode that is precise and efficient in production. AmpereOne is currently the only CPU in the data center space that supports memory tagging. This feature is already available in the Linux kernel today using GCC, glibc, GDB, and ptrace. When users are ready to enable memory tagging, they must simply enable the NB-param feature in the firmware or BIOS. Memory tagging is supported on AmpereOne throughout the SoC, that is the core, mesh, system-level cache, and memory controller. As cloud-native applications continue to evolve, implementing memory tagging becomes an essential for ensuring application resiliency and defense against cyber attacks. Ampere's memory tagging stands out by providing this capability built into the CPU for a distinct advantage over other cloud instances. And you can only find it for the data center today from AmpereOne. Learn more about memory tagging on my blog at www.amperecomputing.com.